Is the very solid pen that you hold in your hand just a collection of whizzing electrons and protons? If so, things are not just what they seem. Hence, science requires bold leaps of the imagination if we wish to discover the truth. Science brings bombs in one hand and medicines in the other. How one uses the products of science has little to do with science itself. Science holds that its results may be verified by anyone repeating the same experiment under the same conditions. Scientific theory dislikes surprises. The relationship between science and mathematics is intimate. However, science can and does deal with bodies, liquids, gases, chemicals, magnetism, waves, electricity, and so on. Mathematics is primarily lodged in the mind. It is a drama in which symbols have the choice roles. The airplanes that carry food aid to starving countries can also drop bombs on them. Therefore, science itself is and remains neutral. It is people who decide on good and evil, not science. The large-scale practical application of scientific methods to buildings and machines and human life goes back less than 300 years. The development of engineering and technological processes was needed for industrial production. Science proposes the methods that work, but engineering has to provide both the materials and the tools for the job in hand, and make the necessary implementation with technological help. Science operates on a take it or leave it kind of approach. The engineer, however, has to use scientific methods to produce something which will be shown to work. It is possible, but difficult, to be a scientist and an engineer at the same time. Normally, science and engineering go hand in hand, and engineering often gives its other hand to technology. From the beginnings of time, human beings have used herbal remedies. They have studied the chemical effects of botanical products on the health of human beings. The ancient Egyptians developed the preservation of dead bodies into a separate science. Serious science begins with serious curiosity. A theory is valid until displaced by a better or more correct theory. The ancient Greeks realized this and thereby laid the foundations of early science. Aristotle, perhaps, was not a great physicist. He was twice married, but apparently did not count the number of teeth of his wives. In less scientific matters, however, he was far ahead of his time. His studies of ethics and of memory are still important. Pythagoras did not always get it wrong. The first step is never to solve the problem. The first step is to isolate and clarify the problem. The solution obtained may be plausible but incorrect and will need to be changed or improved. This is how science works. Nothing succeeds like success, as was proved by Eratosthenes 2000 plus years ago. By observing the shadow cast by a rod at noon in two different places in Egypt, he was able to calculate the circumference of the earth. Clearly, Eratosthenes did not think that the earth was flat. He was an astronomer, and he had studied the movements of heavenly bodies. That is what led him to his calculations. The value for the Earth's circumference, calculated by Eratosthenes, assumes the Earth to be a perfect sphere. But the result obtained is remarkable for its time, in spite of the error in it. Archimedes of Syracuse in Sicily made profound discoveries in mechanics and hydraulics, which are valid even today. He is the most celebrated natural scientist philosopher of his time. Archimedes was the first known person to have calculated accurately the volume and the surface area, both for a sphere and a cylinder. It is said that a sphere and a cylinder in stone were placed on his grave. The focus of scientific development moved away from the Greeks after the 6th century to the area we now call the Middle East. The Muslim empires in Baghdad and in Spain created many centers of learning. During these centuries preceding the Renaissance in Europe, the foundations of modern science were laid in physics, chemistry, mathematics, astronomy, and the biological sciences. The scientific study of chemistry meant that magical tasks like transmuting base metals into gold and creating the elixir of life were pushed into the background. A systematic evaluation of all organic and inorganic compounds became possible. The great Sir Isaac Newton once said that if he had been able to see further than others, it was because he had stood on the shoulders of giants. Khwarizmi may be counted as a giant in the area of mathematics. Al-Razi, known in European literature as Rhazes, was an all-round scientist. His books on medicine were translated into several languages. He was the first to use animal gut for sutures and to make casts out of plaster of Paris. Al-Haytham, otherwise Al-Hazen, was the first scientist to conduct a systematic study of light reflection with spherical and parabolic mirrors and light refraction with lenses. He has a crater on the moon as well as an asteroid named after him. Ibn Rushd, known as Averroes, was a polymath born in Andalusia, or Muslim Spain. His books cover an astonishing variety of subjects, from astronomy to law, and from politics to the theory of music. Ibn Sina, or Avicenna, was one of the greatest thinkers who ever lived. His prolific output ranges from medicine to astronomy and from theology to poetry. He is a household name in the Middle East and South Asia. As early as the 9th century, Al-Jahiz discussed topics like evolution and natural selection. He was also a scholar of literature, theology, and sociology. Al-Jahiz has also translated Aristotle from the original Greek into Arabic. Al-Biruni was conversant in Persian, Arabic, Sanskrit, and Turkish, and read Greek, Hebrew, and Syriac. He has been given the title of the first anthropologist. With his background in mathematics and earth sciences, he has also been called the father of geodesy. Ibn Zuhr, or Avenzoar, was born in Seville in Spain. Apart from writing books on medicine, he was the developer of a school of surgery that conducted surgical operations on animals to check if similar operations could be performed on human beings. Ibn al-Nafis was born in Damascus and studied medicine. He became an expert physician and was the first to describe the circulation of blood to and from the lungs. Al-Nafis was also a scholar of jurisprudence and wrote books on law. The Renaissance, or rebirth, began in Italy in the late 14th century and spread all over Europe. The plague pandemic, or the Black Death, which peaked in 1348 in Europe, had reduced the population of Europe by almost a half. The Renaissance involved discovering the new as well as rediscovering the old in the arts as well as the sciences. Galileo was an important figure in the Italian Renaissance. Galileo had great curiosity, backed up by much analytical and experimental work in mechanics and hydraulics. Galileo got into trouble with the religious authorities because he said that the earth moved round the sun. At the time, people argued that the universe was geocentric, that is, the earth was at the center of everything. The next few slides will deal with Isaac Newton's extraordinary contributions to science and indirectly to mathematics. Born posthumously and also prematurely, Newton was the son of a farmer in Lincolnshire, England. His mother remarried when he was 3, and Newton's relations with her remained unfriendly. Newton himself never married. In his lifetime, Newton provided numerous examples of the remarkable way in which he solved the most abstruse mathematical problems. Newton had a most fertile brain which focused on the problem till he solved it to his satisfaction. The story of the apple falling on Newton's head and waking him up to the theory of gravitation is colorful, but in fact Newton's mind had been occupied with the problem of attracting and repelling forces between bodies for a long time. The crux of the matter was provided to Newton by the astronomer Halley, of Halley's comet fame. Many observers of the motion of the planets around the Sun had observed that all these orbits were elliptical in shape. If the gravitational force decreased with the square of the distance between two bodies, the path of the orbit for a planet around the Sun would be an ellipse, and this was mathematically proved by Newton. Robert Hooke has been called England's Leonardo da Vinci because of the vast range of his interests and achievements, from astronomy to architecture and from languages to experimental mechanics and watchmaking. Hooke had the advantage of working under Robert Boyle, who is known for Boyle's law of gases. Robert Hooke was one of the earliest members of the group of scientists in London that became the nucleus of the Royal Society. Like Newton, with whom he had his agreements and disagreements about gravitation, Robert Hooke never married. Hooke's law has served as the constitutive equation for materials in engineering for centuries. Although the importance of the post-elastic strength of materials like steel and the nonlinear behavior of other materials is recognized, Hooke's law remains vitally important in the mechanics of materials. In Robert Hooke's time, it was customary not to announce but to hide scientific discoveries, so that others might not take credit for them. Only after proper publication could the discovery be announced to the scientific community. It was Lavoisier who was responsible for naming both hydrogen and oxygen. Lavoisier was also acquainted with Benjamin Franklin, who spent 10 years in France as a diplomatic representative of the United States. Lavoisier's groundbreaking discoveries in chemistry were so significant that all his books were translated into English almost as soon as they were published in France. Lavoisier came from an aristocratic family of France. The violence and anarchy at the time of the French Revolution resulted in the assembly under Robespierre branding him as a traitor. After Lavoisier's execution, the great scientist Lagrange said, "It took them only an instant to cut off his head, but France may not produce another such head in a century." In the 19th century, as a result of improved communications by land and sea, science ceased to remain local or even national and began to become international. The achievements of some selected 19th century scientists will now be presented. Michael Faraday was the son of a blacksmith, but as a boy he was the apprentice of a bookbinder, and this resulted in his love of books and learning. Faraday worked in many areas such as chemistry and physics, but his greatest contributions were in the field of electricity. In 1853, he refused to assist in the development of poisonous gas to be used for military purposes. Charles Darwin's maternal grandfather was the rich manufacturer of porcelain and china called Josiah Wedgwood, and his paternal grandfather was Erasmus Darwin, a leading thinker of his time. When he died, Charles Darwin was buried in Westminster Abbey in London. Louis Pasteur is regarded as one of the founders of bacteriology. He was a renowned chemist who also worked on immunology and vaccinations, developing the first vaccines for rabies as well as anthrax. Pasteur is also famous for saying, "In the field of observation, chance favors only the prepared mind." James Clerk Maxwell was a scientific genius who worked out the theory of electromagnetism. Albert Einstein has said, "The special theory of relativity owes its origin to Maxwell's equations of the electromagnetic field." Ultimately, even radio and television derive from Maxwell's discoveries. Dmitri Mendeleev suffered from the early deaths of his father and mother and had difficulty in completing his education. Mendeleev himself had poor health. However, he finally became a professor of chemistry in St. Petersburg. His greatest discovery is the grouping of the chemical properties of elements and predicting the existence of then unknown elements like gallium, germanium, and scandium. When it comes to the 20th century, there is no shortage of illustrious scientists, and inevitably, therefore, one has to select a few examples. In the next lot of slides, the achievements of some notable 20th century scientists will be recounted. Marie Curie was a brilliant scientist who was appointed the first woman professor of general physics at the Sorbonne in Paris. Her work in radioactivity was universally recognized. President Harding, as well as President Herbert Hoover, made contributions to her research on behalf of the United States. Albert Einstein realized the shortcomings of Newtonian physics when it came to reconciling mechanics with electromagnetic theory. He worked towards producing a unified field theory that would include gravitation as well as all other forces. Einstein and his family were non-observant Jews, but this did not prevent him from being mistreated by the Nazis. He had to leave Germany, eventually reaching the United States. Edwin Hubble was a brilliant scholar. He got a degree in mathematics and astronomy from the University of Chicago in 1910. He promised his father that he would study law, which he did as a Rhodes Scholar at Oxford. He passed the bar examinations but did not make the law his career. Hubble was a colorful character. The day he passed the examination for the Ph.D. degree, he went off to Europe to fight in the First World War. Curiously, as a world-famous astronomer, he also went off to fight in the Second World War. Max Planck's professors were Kirchhoff and Helmholtz, and he also did work in thermodynamics and the energy of radiation. Max Planck remained in Germany as a university professor at Göttingen, although he was hostile to the Nazis. Of Paul Dirac, it has been said that his discoveries were like exquisitely carved statues falling out of the sky one after the other. Dirac was a reluctant talker, except to a few people. He used to climb trees dressed in a three-piece suit. However, he was the first person to propose antimatter, and he also did first-class research in quantum mechanics. Niels Bohr gave more thought to the structure of the atom than any other scientist of his time. He was able to combine the atomic nucleus of Rutherford with the quantum theory of Max Planck. In later life, Niels Bohr also worked in molecular biology. Stephen Hawking grew up in an educated family where dinner was a silent affair, with everyone reading a separate book at table. After graduating at Oxford, Stephen Hawking did a doctorate in cosmology at Cambridge. Although not fully fit, his illness got the better of him after he turned 21. However, since that time, his appetite for theoretical work has apparently remained undiminished. It is easy to observe that because of the importance of scientific discoveries over many centuries, and also the continuing progress in all areas of science today, the study of the history of science is itself an important academic area. Research is a search for the unknown. It is starting the engine of the mind with a sense of direction, even if the road is very bumpy. Research is mentally collecting and collating every bit of available knowledge and scrambling the bits to see how they fall. In the 20th century, systems to be analyzed became large and complex. The structure of airplanes, the interaction of world economies, issues of global health, and problems of shifting commercial products all began to result in mathematical formulations containing thousands of equations. The systematic storage of large amounts of equations became possible only after computers were put into operation. As will be observed in the next few slides, the computer is a very versatile and useful calculating tool. The computer can perform wonders in calculations, but it can only work according to its own given logic. The story is that a computer was programmed to answer questions. A kid came up and asked, "Say, what's up?" and the computer burnt itself out. The computer by itself is not intelligent, but human beings can graft intelligence onto the computer by enabling it to compare and judge items. This facility greatly extends the usefulness of the computer. The history of computers virtually begins with Konrad Zuse, who produced a programmable computer as early as 1936 in Germany. The first programming language in which instructions could be given to the computer was also developed by him, and he called it Plan Calcul. Progress in the development of computers increased by leaps and bounds after the Second World War. From the beginning, the trend was towards producing faster and smaller computers. The demand for number crunching became greater and greater, and this led to the manufacture of the first working computer called ENIAC, which took up a huge amount of floor space. Those of us today who carry USB memory sticks of 32 gigabytes that weigh less than half an ounce may easily observe how much has been achieved in weight reduction in the computer world during the last 50 years from this slide. In computers, virtually from day one, there has been no looking back. More and more compact machines have continued to appear on the market. Initially, punched cards were used to feed data into computers, and this was a rather cumbersome process. Computers in recent years have become much more user-friendly, with a lot of applications, not all of which may really be required. The market used to be dominated by portable desktop computers, but currently tablets and cell phones incorporate all important computer features. Today we are all living in an era where greed for wealth appears to be more important than service to mankind. Scientists can do their part to ensure that science ultimately results in the greatest good of the greatest number. Even commercially driven groups and companies are now waking up to the fact that improving the quality of life on this planet may also be economically very profitable. We take the impact of science on our lives for granted because most of the changes in our daily living are due to the products of science. These products come about by way of engineering and technology. Older people can easily remember a time when there were no cell phones or even no microwave ovens. Science has contributed immensely to our lifestyle, but in the end, we must remember that there is a delicate balance in life. One has to pay for comfort and convenience by saving energy, removing pollution, and using only sustainable technology. The next few slides show present applications of green technology. As we approach the end of our presentations on science, we need to reiterate that just as mathematics is intimately linked to science theoretically, so mathematics as well as science are both linked practically to engineering and technology. These relationships will be shown in subsequent presentations. With a burgeoning world population, as well as increasing energy requirements, not to mention challenges of health and disease, the whole world looks up to scientists to provide the breakthrough discoveries that will turn the world into a land of milk and honey. There is no doubt some hope in this attitude. Science and all its component areas are often considered to be no more than an intellectual pursuit, or, on the other hand, just a mundane profession. However, science is more than the scientist's daily bread and butter. There are, indeed, moral ramifications to every scientific discovery. The scientist, perforce, has also to think on behalf of the masses of this world.